In this video, we're going to look at an example of finding second partial derivatives. So we're given the function f of xy equals natural log of ax plus by, and it asks us to find all second partial derivatives. So since we have a function of two variables, we would have two first partial derivatives. And then each of those is a function of two variables, so we end up with two second partial derivatives for each of those two partial derivatives, which means we're going to get four second partial derivatives. Notice in this problem, it told us the function was f of xy, so that's telling us that we're treating a and b as constants in this case. Okay, so we're not worried about taking partials with respect to a or with respect to b in this case. All right, so partial with respect to x. Outside function is natural log. We get 1 over the inside, so 1 over ax plus by. Derivative of the inside with respect to x is going to be a, and then a plus 0 here, since the y is treated as a constant. I'm going to rewrite that with a negative exponent. That should just help us be able to take the second partial here in a minute. Likewise, for the partial with respect to, that should be a y, not a b. That's my bad on the subscript there. This should be f sub y of xy, because we're doing the derivative with respect to y. Well, again, chain rule, 1 over inside, since we're differentiating the natural log. Now we're differentiating the y. The derivative of the inside is just a b. And again, here I'm rewriting that with a negative exponent in anticipation of doing another derivative here in a minute. Okay, second partial with respect to x. I go back to my first partial with respect to x and differentiate it with respect to x again. So our outermost function here is a negative 1 power. We bring that down and decrease the power by 1. And then differentiate the inside with respect to x. That's where the a comes from. Now notice that we get an a squared and this thing squared. So if you simplify, you can rewrite it as the negative of the quantity a over ax plus by squared. For the partial with respect to x and then with respect to y, I go back to the partial with respect to x and differentiate this thing with respect to y. Notice that the first part of the derivative looks just like what we had in the previous part. The only thing that's different is when we go in and take the derivative of the inside, we get a b. So now the numerator becomes ab, and then we get it over ax plus by quantity squared. For the partial of y and then with respect to x, we go back to the partial with respect to y function here and differentiate with respect to x. Again, the outside function here is a negative 1 power, so we bring the power down, decrease the power by 1. Again, now we're differentiating the inside with respect to x, so we get an a for the derivative there. And notice that this derivative matches the other mixed second partial. Finally, we want to do the second partial with respect to y both times, so we go back to the first partial with respect to y, differentiate it again. Again, we're going to bring the power down, decrease the power by 1. But then when we take the derivative of the inside, we're going to differentiate the y in this case, which gives us the b. Then if we pull out the squaring, we'll get an opposite of the quantity b over ax plus by quantity squared.